I'm Anil Kumar, and in this video we'll discuss even and odd degree symmetry for polynomials. I hope this video can form a base for you. So let us consider a few functions which may be even. I'm not saying they are even symmetry, but we'll take few polynomials which have even degree. Let me put it like this. Let us say we have a function f of x. Even degree really means that the leading coefficient, the leading or the highest degree is even. So let's make this as, for example, 4. So this becomes an even degree polynomial. And let me write here as 2x cubed minus x plus 1. And on the other hand, let me use some polynomials which are of odd degree. Let us say x to the power of 5 plus x cubed plus 2x. Right, so I'm not adding anything to this. Now the question here is this polynomial with even symmetry or not? It is even degree polynomial, but does it have even symmetry or not? That is the question. Now here we have a polynomial with odd degree. Is it also a polynomial with odd symmetry or not? So remember one thing, degree of a polynomial could be even and odd, but necessarily even degree polynomial may not have even symmetry. Same is the case with odd degree polynomials. Now condition for even symmetry is that if you calculate f of minus x, you should get f of x. That means even symmetry. But if you calculate, let me write f of, doesn't matter. And if you get minus of f of x, in that case it is odd symmetry polynomial. So that is odd symmetry. And this one means even symmetry. When you sketch a graph, even symmetry polynomials will be symmetric about y-axis. So this is symmetric about y-axis, and the odd degree are symmetric about origin. Let me say 0, 0. A point, it has a rotational point symmetry. And the point is origin always. Okay, that is how it is. Now let us test whether the given polynomials for us have the required symmetry or not. So we'll calculate f of minus x. So that is the step. So replace x with minus x. What do you get? You get this, right? So I'll quickly do it. Just replace x with minus x. Now even degree will make it even. So it is x to the power of 4. Minus odd, so it is minus 2x cubed. Minus minus makes it plus x, and this is plus 1. You can clearly see that f of minus x is not equal to f of x, right? Since we have a term which is not matching. Do you see this term? It is not matching. So the given function is neither. Do you see this is neither? It is not even function. Now what makes it neither? As you can clearly see that the term which makes it neither is this particular term, as this is the term which is not matching. So what we note here is that if even degree polynomial has all even degree terms, only then that polynomial will have even symmetry. You get the point. So you can do this calculation for another polynomial. Let's call it p of x as, let us say, 3 times x to the power of 6 plus, we are avoiding odd terms and we're adding even terms, 4 minus 2x squared. Now if I write here minus 3, this is also even since x is to the power of 4. You will notice in this case that p of minus x is equal to p of x, and this one is indeed even symmetry. The reason is that all terms should have even degree. Then polynomial has even symmetry. Otherwise not. Okay. Same is the case here. Now in this particular case, if I do g of minus x, what do I get? I get minus x to the power of 5 plus minus x to the power of 3 plus 2 times minus x, and that gives me minus x to the power of 5 minus x cubed minus 2x. I can take this minus term common, so I get x to the power of 5 plus x cubed plus 2x, and that is equal to minus of g of x. Since g of minus x is minus of g of x, this function has odd symmetry. Do you see that? And the test here is that all terms have, I should say odd, right? Odd degree. Therefore, we have odd symmetry. So the idea here is that you can visualize and check whether the given polynomial will have even symmetry or not, will have odd symmetry or not, right? So that is very important to note. Now, as an exercise, can you give me examples of polynomials with even and odd symmetry? Let me give you the ones which are the most simplest of all. For even symmetry, the most simplest is a constant. For example, if I write y equals to 5, then it has even symmetry, right? It is always 5 symmetric about y-axis, a horizontal line. And odd symmetry, the best example and the simplest of all, is the one with degree 1, which is y equals to x. So that is odd symmetry, right? So these are good examples. You could have other examples also. For example, you could have y equals to x squared plus 2, and in this case you could have y equals to x cubed plus x, for example, and so on. You can create your own examples with even symmetry and odd symmetry. So what we notice and learn from this video is that if we have a polynomial with many different terms, then if each term has even degree, then the polynomial will have even symmetry. And if each term has odd degree, then it will have odd symmetry. Correct? That is what it is. Now here is a test question for you. You need to find symmetry for, so the question here is find symmetry whether this polynomial, let us say x squared minus 1 to the power of 2, will this polynomial have even symmetry or odd symmetry or neither? Treat it as your test question. Thank you and all the best.